Anybody? No. Okay. For the following exercises, find the average rate of change of each function on the interval specified. On the interval specified, right? So what that means is they're going to give us a function. Let's see. Yeah. Oh. Do you work? Yay. All right, so if they give us some function, and I know this didn't give us a picture, but if they give us some function and they ask us to find the average rate of change on the interval something to something. A to B, right? That's exactly what this is saying. They didn't give us a picture. It's okay. We don't need the picture, but I just want to give us a visual for a minute. So let's say here's A, and here's B. So what is this? What is this value right there? I know, you're like, I don't know, dude. You didn't tell us what the function is. But it's f of x. So what's the output if the input's A? No, B is this point over here, right? B. So from A to B, if I put an A into the function, what do I get? I know, that's a weird question, right? But you ready? Huh?
Whatever that is.
F of A. Okay, so this output is f of A. Now, how would I figure that out if I just knew this? Wouldn't I just plug it into the function, whatever the function is? Right? What about this point? What's this point? I know it's B something. F of B. And how do you find the slope between these 2 points? Yes? If it's a straight line. How do you find the slope between any 2 points? What's the little...
x2 minus x1, y2 minus y1.
Yeah. What goes on top? Well, yeah, y2 minus y1 over x2 minus x1. So what does it have to do with the problem we're talking about? Well, they gave us a function, right? On number 6, they gave us a function, and they gave me an interval. Can you figure out the 2 points? What's the point that goes with 4? 4 comma what? What's that point? Do you know the function? What's the function that we're working with on number 6? 2x squared minus 9. Yes? Yes? How do you... All right, so 4b, that's an interval on the x-axis. So on that interval, I want to know how much the function changes. You with me so far? Right? So average rate of change is slope, and I need 2 points to figure out the slope. Well, do I know some inputs? Yes. I know 4 and I know b. Right? So I need to figure out what g of 4 is and what g of b is. So for, let me switch over. Okay. What is the point related to this one? 4 comma what? How do you figure that out? Plug it in, yeah. What do you get when you plug 4 in? G of 4 is twice 4 squared minus 9. Maybe a little more, yeah. Right? You guys with me? How do you get a point? Well, if I know an input, I put it in, I get an output, I get a point. You with me? What told me to do this? I know average rate of change means slope. And the most basic way to find the slope is to have 2 points. They gave me a function so I can make the points. I know the inputs. So what's 1 point so far? What's this? Yeah, so it'll be 32 minus 9, 23. So I got 4, 23. What's the other input? The other end of the interval? B. Now, if you're freaked out about that, I'm sorry. You shouldn't be. You should be. Who cares? It's just a B. So what's g of b? I got to figure out what that point is. What's g of b?
2b squared minus 9.
2b squared minus 9. And then how do I find the slope? And I know the point looks gross, right? The point's not numbers, it's got b's in it. Who cares, Matt? Now, we care a little bit because that means we have to do some stuff. But just to set it up, how do you always find the slope between 2 points? Right? y2 minus y1. Let's call this one the second point and this one the first point just because. So y2 is 2b squared minus 9 minus y1, 23. Right, yes. Over what? What goes on the bottom? What goes on the bottom of the slope always? X2 minus x1. So what's x2? B. And what's x1? 4. So setting this up doesn't change. I created 2 points. How do I always get the slope between them? y2 minus y1 over x2 minus x1. Now, the parts are gross. Who cares? I can still at least set it up, right? I can at least get this far. Because I'm just throwing stuff in. I'm not doing anything with them yet. I'm just putting them in. So on that level, you should be like, all right, just throw shit in and hope that it kind of gets somewhere I can see what to do. So what can you do on the top of this? Is there anything to do on the top of that?
Combine like terms.
Yeah. So you get 2b squared minus 32. Any other ideas? Don't stop there because what can you do on the top? What do you do when you see something with variables that's a ratio? What do you try to do? What do you always try to do with a fraction that's sitting there staring at you? You try to simplify it, right? So, and what's simplify mean? See if there's any common factors. Okay, so that means I have to factor the top so I can see what it's made of. How do you factor the top of that? So you got a 2. Keep going. Yeah. It's a little thank God problem. And then what happens? So you get 2b plus 8. Now why is our answer not a number? Because they didn't give me a number input. So I expect my answer is going to be dependent on what that input is. If they change b, then my answer is going to change. So back to this. There's a slope here, right? Between those 2 points, there's a slope. If I move this point a little bit over, will the slope change?
Yes.
Yes, so I expect my slope to be a function of b because it will change as I move the second point. So let's do a concrete problem. That one is a little weird. It's got a b in it. Kind of threw us off a little bit. Let's do one that we can actually graph the problem. How would I graph y equals x squared minus 4? What's a nice quick way to do that? There's a few answers I'll accept here.
A parabola translated down 4.
Yeah, kick ass! Sorry. Got a little excited. So normally it's at 0, 0, 1, 1, negative 1, negative, right? Here's my base parabola. Scheisse. I highly recommend learning how to cuss in many languages. And then, that, like you said, it's going to go down 4, yes? That's that transformation stuff we learned yesterday. So I'll just take every point down 4. This point goes 1, 2, 3, 4. 1, 2, 1. All right, so here's a picture of it. Should really go through 2, but that's all right. So let's say I want to know the slope between... I should have made this better. It's too bad, Jeff. All right, I'm going to try to make this better. This should really go through 2. How do I make this better? There. All right. Should have been more careful. So let's say I want to know the slope between these 2 points. I want to know the average rate of change on the interval -1 to 2. I want to know the average rate of change. So far, so good? So from this point, didn't it go down a little bit?
But then didn't it go up so much?
So what's the average change would be how much actual height over how much time. That's like a speed, right? How quickly did it rise over so much time? That's the speed. That's what average rate of change is. So what do I need to be able to find to get the answer? How do I find average rate of change means? And what do you need to get the slope? 2 points. Don't we have the 2 points? What are the 2 points?
-1, -3, 2, 0.
Kick ass. Right? And again, if they didn't give us the picture, we could just throw these numbers in to figure out what the outputs are, yes? And now that I got 2 points, it's simply find the slope. And that needs to be like, oh, thank God, it's just finding the slope. That needs to be that right now. If I ask you to find the slope between 2 points, you should go, holy shit, yes, fantastic, give me more of those. It's got to be easy as shit. Yes, it's got to be. So what's the slope between these 2 points? How do I get that?
-3 minus.
Okay,
0.
so you can go this way. -3 minus 0 over
-1 minus 2.
-1 minus 2.
-1.
So you get -3 over -3 is 1. Why does that make sense? Is this a positive slope?
Yeah.
Yes, it went up over time, so the rate of change should be positive. It increased over time. Now, didn't it go down a little bit from there, like I already said? But then it went a lot up, so overall, it averaged going up a bit. Maybe? Is that better? Is that meh? Something is like, I feel about the same as they did. All right. So this problem was strange because they didn't make it concrete. They made it a little more abstract because they gave me one of the things was B. But the process doesn't change. The process does. What did we do? What was the last thing we did? What was the last thing we did? What was the very last thing we did in this problem?
Simplify.
Yeah, we reduced. We canceled common factors, yes? One thing I love to say is, I might say this a few times this semester, what's a variable? What is a variable?
Number.
Good. Yeah, I'm sorry. I had a little too much caffeine, I think. A variable is a number we don't know yet. So how can variables act the same way numbers act? Because that's what the hell they are, right? So I have an expression with variables in it. Who gives a shit? What do I do with a fraction? What do I try to do with it? I try to simplify it. I don't care what's in it. And that involves factoring. So if I have numbers, we normally don't even think we're factoring, but we are thinking 8 over 4, oh, they both have a 4 in them, right? So when I have variables, I got to really be more, so let me actually break this thing up so I can see what they have. All right, maybe. No? Here, what was the next problem that you had to do on that one? 6, 9, maybe? 9. Was it 9 that you had to do? Hello? Anybody? What was the assignment? Here, just do 9 right now, everybody. Try to do number 9 up there. Oh shit, let me change over. There we go. Can I do this? Oh shit, I can't do that. Sorry. So old man fascinated by a touch screen. Number 9's even funkier. I love it. Just to make sure everybody's on the right track. What are the 2 inputs for this problem? What are they specifically? Yes, x. So you're going to have one point is x comma something. And the other point's going to be x plus h comma something. How do you figure out the somethings? Say again? Plug them in. Yes, yes. Are they going to be nice? No, probably not. At least the function, well, what's this one? The function is nice and funky. I like it. what are you guys doing first? It's the first thing you have to figure out.
Just distribute. the-
Yeah. So you wanna figure out the output for each of those inputs, right? You wanna finish their points, right? Now again, is it gonna be pretty? It's not gonna be a number, but it's not gonna be that hard either. You guys know how to foil shit, right? It's more than you wanted, but it's not like crazy. Or, you know, I don't know. So let me see if you guys, so this is the way I would set mine up a little bit. So I gotta figure out this point, x comma something, and I gotta figure out this point, x plus h comma something. Now what's funny about this one, what's the input for this point? What's the input for this point? X. And when you put an x in, now you tell me, what do you get out? If you put an x in, you get 2x squared plus 1. So that point is already kind of given to us, right? When I put an x in, I get 2x squared plus 1 out. That's what the function directly tells me. No work to do. Next one's going to be more interesting. How do I figure out x plus h comma something? What do I have to do? Yeah, plug it in. So again, notice what we're doing. The question said, what's the average rate of change? You immediately replace that phrase with slope. Then you realize, how do I get the slope of something? I need 2 points. So then you're focused, I gotta make 2 points so I can set up the equation, right? So again, it's not about the specific thing, it's why am I doing that? To figure out the output. So I can get a point, right? Once I got the 2 points, I can get the slope. I know it's not numbers, but who cares? The process stays the same. So if I plug an x plus h in, what does it look like very first thing? Before I do anything. Plug an x plus h in. 2
x plus h squared
x plus h all squared
plus 1.
plus 1. So what should I, of course, somebody already said this, but I want to kind of simplify that, right? So what do I get when I FOIL this?
X squared plus 2xh plus h squared.
Right, if you want to see that, if you can't see that, then you write x plus h twice, right? So you can see how to FOIL that bad boy. Is that cool? So notice how each single step involved in this problem is not difficult. But as a student, it is really easy to think of the entire problem at once in your head. You're like, oh my God, no, just focus on one thing at a time. I know that seems really simple. So let's see, we get 2x squared plus 4xh plus 2h squared plus 1. That's what that is. So what are my 2 points? I have x, 2x squared plus 1, and I have x plus h comma, all that. Is that what you hoped it would be? No. You guys sort it with me? Oh no, what have I done? Holy shit. Okay, there we are. Again, I don't know how to get this. Whatever the points are, whatever they are, whatever they look like, how do you get the slope? Let's call this one the second point, right? So what do I put up here? What has, in general, what? y2 minus y1 or x2 minus x. So what's y2?
2x squared plus 4.
Yeah, 2x squared plus 4xh plus 2h squared plus 1. And then I do minus y1. And what's y1?
2x squared plus 1.
Now I'm going to make a mistake. There, I've made a mistake. What mistake have I made?
That should be minus because the whole equation is minus.
I've got to subtract this whole thing, right? Is that cool? That's the most commonly made mistake, is to forget to put parentheses around an expression. You got to subtract the whole thing. It's what it says y2 minus y1, the whole y1. And what goes on the bottom? What's x2?
X plus h.
X plus h, and what's x1?
X.
That bottom looks cool. Let me do the bottom. You, all right, I did half of it. Sorry. On the top, what happens? The top looks really cool too. What happens on the top? 2x squared minus 2x squared. Gone. 1 minus 1.
Gone.
Gone. So what's left? 4xh plus 2h squared. All right. Can I just kill these h's here?
No.
Good, no. But I can cancel an h, but I just got to make sure I cancel an h everywhere. So what's left?
4x.
4x
H squared.
plus 2h. I just lose an h, right? I'm dividing an h out of each of those. Now, I know some of you guys don't believe me, but we did the exact same work just now as we did when the points were -1, -3, and 2, 0. We did the exact same work. Does it look a little worse? Yeah, because there's parts of it we don't know, but I really want you guys to see the process didn't change at all. Make the points, set up the slope, simplify. That's exactly what we did when we had numbers. Just the simplify step is worse when you have variables, right? But I really want you to see how you can just sort of, okay, I don't know what the hell's going to happen, but I know, let me just get things set up and see what jumps out at me, right? Instead of just going, I'm not going to do that problem. Yes?
So for the denominator, isn't it x plus h parentheses negative x?
Say, yes, so what's 8x plus, what do you mean? Wait, isn't it what?
Like in parentheses, like do you have to, the one that you did on the top, so 2x squared plus 1 is in the parentheses and we have to multiply the minus sign. Isn't it the same at the bottom? Like denominator?
Multiply the minus sign, I'm sorry.
Yeah.
Here.
Yeah.
Okay. Well, I did, minus x. So I made everything, what's x2? So here's the 2 points, yes?
Yeah.
Here's y2, that's why we put it here, and here's y1, yes? What's x2? What's the x piece of the second point? X plus h, yes? So I put that here. Minus, what's the x piece of the first point? What's x1? X minus x. So I'm not sure, what is it you think we need to do?
Isn't it in parentheses we have to multiply negative sign?
Of course. But where's the parentheses?
So isn't it the x plus h? It's only, it's one number, right?
Yes, I love it. X plus h, sure, it's a
Yeah.
number. I love it. So you want me to put this in parentheses?
And then, can we just multiply negative signs so it's going to be
There's no negative out here though. Right? This is positive x plus h minus x. So if it looked like this here, then we would distribute the negative, right? Is that cool?
Yeah.
Okay. So this doesn't say x plus h times negative, no, it says x plus h minus. Right? So there's no negative to distribute. There's nothing, there's just a 1 out front here, right? Okay. So let the bottom be nice. The bottom is the second x piece minus the first x piece. And the x's cancel, so you just get h. It's awesome. Maybe, is that all right? I have this feeling that the answer is no to that for some of you guys, but you're not telling me, so can't do much with that.
It just wasn't like intuitive to me to,
Another answer.
distribute out the,
This guy?
that guy, that's, yeah, the big one.
This guy here.
Yeah,
And so doing this wasn't intuitive? Is that what you're
yeah,
saying?
but I understand why.
Okay.
Just to kind of put it all together and simplify it down.
Yeah, so look, all right, let's do another, real quick, another concrete example. So if I gave us f of x equals x cubed minus 2x, right? X cubed minus 2x. I don't want to find the average rate of change, real quick. I don't want to spend all day on these problems, but average rate of change on 1, 3. So, and again, average rate of change means slope. I need 2 points to get the slope. How would I get the 2 points? are my two inputs that I'm using? 1 and 3, right? Okay. So I know I have a 0.1 comma I don't know, and I know I have a 0.3 comma I don't know. Right? I have one input is 1, and the other input is 3. If I could just complete that point for each of those, I can get the slope easy. So this does relate to your question, I know. So how do I figure out what I put here? Plug in
You do F of 1.
f of 1, and what do you get?
Uh,
1 cubed minus 2 times 1, right?
Yeah.
Would I put 1 cubed minus 2 times 1 there?
No.
Of course not. I would simplify, right, to figure out what the hell it is. So that's such an automatic thing that we do. We don't even realize it. But again, I do everything I do with numbers, I do with variables. So once I plug it in, what do? Simplify as much as I can. That's what we do with numbers. I wouldn't put that shit there. Why would I put that shit there? Right? I would put, like you said, I would put 1 minus 2 as -1. I would put -1 there. Of course I would. And just to finish this up real quick, what's f of 3? 3 cubed minus,
minus 2 times
I like it. And what's that?
21.
Yeah, 27 minus 6, 21. Right, and then you just have to find the slope. 21 minus -1, 22, over 3 minus 1, and I get 11. Yay! Is that all right? But notice how everything we just did is the exact same stuff we did here. I know it doesn't look like it. But didn't we have an input? We put it in, we simplified. Exactly like we did with the 1 and the 3. Exactly like we did. Okay, that's enough of that. That's enough of that. Okay. Any other kind of problem, or is that the only thing you guys have trouble with is average rate of change? I find that hard to believe. Not that I think you have a lot of problems, but there's got to be other things. You can look at the practice test. Everybody got a practice test? I have the answer key I'm going to give you later. Yes?
practice things in number 6 and grade 6 f times f negative to the -4.
See, I'm going to do this. Tell me if this is too little light for you. Is that all right? Whoop.
That's fine.
Is that all right, everybody? Okay. So 6, which part?
F
6.
-4.
Oh, okay. So this is, I'm sorry. So on the answer key, I actually tell you, this, I thought we'd get this far, we didn't. So this is on the next test. Anybody know what that reference is? That -1 power? It's not a -1 power. Anyone know what that symbol means? F to the -1.
Inverse.
Inverse. And that section we haven't gotten to yet. That's going to be on the next test. So that's my fault. As I was making the key, I was like, oh shit. So that's what happens when I decide to move some sections later. I might forget on the practice test. I think there's one more question like that maybe somewhere about the inverse. Number 10, the idea of 1-to-1. Has anyone ever heard of that before, a 1-to-1 function? And that relates to inverses, so that's in a future section. So this is on the next test.
You said we only got up to section 3.5.
3.5, yes, that was transformations. Okay, so that was an easy answer. My answer was, don't worry about that yet. You're like, good, one less thing to worry about. Anything, we can talk about anything. Any issue that you're still having trouble with, anything. Have you guys had a chance to look at the practice test? Anybody? And the list of priorities is actually homework and then, practice test. But even if you're not quite done with the homework, you should really kind of at least scan the practice test. The first time I ever taught, my students ask me, what do your tests look like? And I said, I don't know what my tests, I've never made a test before. So that's one reason why I made my very first practice test. Was it was actually truly a practice test for me, practice putting a test together. And so ever since then, I've done it, made a practice test with a little answer key as an extra study guide. You don't need the practice test if you're able to do all the homework. But the practice test is kind of a nice, just it mixes everything up so that you can kind of verify that you know how to do the various things. Yes?
I think for chapter 3, section 2, the last question, 60, it's talking about like real world applications. The thing is, the function is a parabola, and then when it goes to like the negative side, would we still include it for the domain?
So 3-2, hold on, let me catch up to you. Whoops, shoot. There you go. Yum this thing. What is going on with you? Why are you way over there? Oh, you're a weird thing. There, oh God, okay. All right, what has happened to this? Let me try to refresh. Okay, go away. Okay. So, all right, do it again, sorry, which problem?
For the last problem, is 61.
61?
60.
60, okay. Okay, yeah, this guy. So let's see, the height of a projectile is a function of the time it's in the air. Kind of makes sense. Oh my goodness gracious. You're not gonna move over. What's wrong with this thing? All right, I'll work it out. You guys can see that? Okay. Height of a projectile is a function of the time it's in the air. So yeah, the longer something's in the air, the higher it can possibly go, possibly. The height in feet for t seconds is given by this function, blah, 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 blah. And can somebody tell me anything about what that would look like if you graphed it? It doesn't ask you to graph it, but what would it look like if you graphed it? This guy right here. Parabola. Now be more specific.
Very sharp upside down parabola.
Okay, good. I love it. This is very specific. So is it, at least we know it's down, yes? How do we know it opens down like this? The t-squared part is negative, right? And the fact that it's negative 16 means it's going to be really skinny. It's sort of related to the slope, so it goes down really fast. So it's a really skinny parabola. I love it. Can anyone tell me, so what's the domain of the function? That's kind of a funky question. That's why they did this. Is the domain negative infinity to infinity? What do you think? No. Because this is, we're throwing a projectile up in the air. So at some point, I can't go back in time forever, right? So doesn't it make sense? What should be the very first input? What should be the lowest value for t? 0, right? For most problems, so my domain so far is 0, comma, something. Probably not infinity, right? So the domain, if you want to answer the question, you can say, well, it starts at 0, but I don't know. What's going to happen to make the domain kind of stop, to make it? When it lands. When it hits the ground, it no longer follows the parabola. It's not going to dig into the ground and keep going with the parabola. You know, it's not going to, I don't think. I don't know what this is we're throwing. Okay, maybe. So what does the domain mean in the context of the problem? Well, it's a real physical problem. So therefore, I'm constrained by when I throw it and when it lands, right? I kind of gave all that away. Shoot. Well, that one's a weird problem. I will grant you that. But it's trying to show you how the function itself, if this is just a wild function, doesn't relate to anything. What's the domain? Are there any t's I'm not allowed to use? Any value of t I'm not allowed to use? Why not negatives? Okay, no. Again, take it out of any physical meaning. T is just a variable. Do you understand? It has nothing to do with the real world anything. It's just an equation. What's the domain? All real numbers, right? I can square any number I want to. I can multiply any number by negative 16. I can add it to 96 times the number. Is that cool? Okay, maybe. This problem says, all right, math, that's nice, but I'm in the real world. Normally for us, starts at 0. That's when I start it moving, and that's when it starts to follow a parabola. Before I throw something, it's not following a parabola, right? Okay, maybe. So it's got to start at 0 normally, and then it goes up to something when it lands. Are you guys done with me? So there's no specific number answer for this, to be honest. Right? This is more about just how does the real world limit functions. So a function can have a domain problem because of the math, but a function can also have a domain restriction because of physical world, right? So if I'm building a shed, what's the smallest width possible for the shed? Almost 0, right? Now that's, to be honest, I mean, I don't know, there's got to be some physical limitation, but you can make this, you can imagine you can make a shed whose width is this, and there's this long freaking, what are you going to put in there? You ever seen those trucks that are like this wide? It's basically an advertisement. Maybe. Even some of them, I think you put shit in, but I don't know. All right. I don't know if you guys are with me or not. So that's kind of weird, but I could. Could it be negative? Could this length of a shed, could the width of a shed be negative? No. So you could set up an equation that has no problems with negatives, right? The function itself is cool with negatives, but the fact that it's talking about a shed makes it say you can't have negatives. Does that make sense? So that's the point they're trying to make. So, for example, what's the domain of this function? How would you figure out the domain for, you gonna see it? No. Beep. Do it. Okay. What's the domain for that?
Negative infinity, comma 3.
Yeah, what's the number you have to throw out?
0.
0 is fine.
Or 0 in the denominator.
0 in the denominator, which requires a -3 input. Is that cool? So do you understand why somebody would tell me the domain doesn't include 0 here? Because they're thinking the bottom can't be 0. But I'm talking about x. So you got to think, the bottom can't be 0. What value would make it 0? -3. Okay, I got to throw that shit out. So let's say this, the domain mathematically is this. Is that cool? Everything except -3, right? What if this function describes x is the number of people in an elevator or something? I don't know, right? Just to make some up real quick. Does that further restrict my domain? Hell yeah, right? Can't have negative people. So let me see if you guys could do this. If this is the math domain, right? This is, as far as math cares, this is all the numbers you can put in there. It doesn't care if it represents something or not. But if I have x is the number of people, what does the domain become? What's the least number of people you can have in the elevator?
1.
No? 0. And I wouldn't even do it like that. It'd be 0, 1, 2. It can't even be like, if you have 1.5 people in an elevator, I am not going to step in there. I'm like, what the shit? Is this somebody phasing in and out of reality? I'm half time here. No. Right? Even if they've been chopped in half, they're still a person. They're not half a person. Okay. You guys semi with me? So again, that was the point of that problem, is there could be a math issue with the function. Something like this. It's a fraction. I can't have the bottom be 0. And math says, here's all the numbers that make it not freak out. But if it represents number of people, that puts an extra restriction. So that's all that's trying to say. Are you with me? Are you against me? Okay, you're with me. Okay. So that's a really good question, because that one got a little bit weird as far as what their point was. If you guys don't have questions, I'm going to sort of go through this practice test a little bit. Any other specific or general questions about things? How many of you guys have gone into the Math Study Center for help? Anybody? 2 of you? Okay. The rest of you guys, it's there. It's free. It's better than Craigslist, because Craigslist tutors normally run like $30, $35 an hour. Plus you could die if you use Craigslist. be the lifetime moving. Very few deaths happen in Mass Study Center. In fact, there's 0 as far as I know so far. So you should use that Mass Study Center, right? Okay, maybe. All right, let's go through this. So if I were you, if I really didn't have time to do the practice test, I would sort of scan through this thing anyway and say, what does it look like I would have an issue with? If your answer is everything, then you should probably come get some help. The first 2 questions, I don't want to like true or false in tests, but I wanted to put them on the practice test just to get you thinking. Right? 2E. Say again? 2E. 2E? All right, so on 2E, believe it or not, order of operations. When does order of operations come into play? I love this question. When do you have to worry about order of operations? Always is the answer. They're always in effect because they are the underlying like grammar of math, right? Maybe? So what is order operation? Yeah, sorry.
Can I get a friend?
Sure, of course. That's why I asked earlier. Anybody else need? Yeah? Okay. So on 2E, what's the very first thing in order operations? Parentheses, right? Please excuse my dear Aunt Sally or my son or whatever, right? So parentheses. So what am I going to worry about last in this problem? What's not in parentheses? The -2. That's what I'm going to worry about last. Does that make sense? I have to worry about in the parentheses first. That's order operations. Is there another way to do this problem? Yes. Does it make things worse? Yes. So just follow order operations. What can you do inside that thing? Look at the numbers. Let something be nice. 3/12, right? Ignore the A's and B's. 3/12 is a part of this problem. What is that? Yeah, so what is it? Yeah, so inside, so I'm going to put, okay, so I'm going to put this like this, I'm going to put a -2 on the outside. So inside, I have a 4 down here now, right? Is that cool? Because 3/12 is 1/4. Anything else in those parentheses that can be done? Yeah, what's a negative power mean? Flip. So what wants to flip? What's the only things that want to flip? Which A's and B's? You gotta be careful. There's 2 A's, there's 5 A's, there's 3 B's, there's 1 B. Yeah, the 5 A's want to flip, yes? So the 5 A's come up, and there's 2 A's already up there. How many A's are up top? Was that, do you guys see what just happened? I don't actually have to even do anything. I just know that a negative means flip. So those 5 A's come up. There's 2 already up there. So now there's 7 up there. What else wants to flip? 3 B's want to flip. So when they come down, there's 1 B down there already. How many B's are going to be down there now? 4. All right, so that's step number 1, right? So the numbers you do like you always do. You just reduce them. I'm getting people tell me that that becomes 1/9. What did that person do? They think 3/12 becomes 1/9. They subtracted. Why do you think they thought subtraction was right to do? What do you do when you divide things with powers? What do you do to the powers? Subtract them, right? So that's why suddenly they think, oh, now division means subtract numbers. No, hell no, shit no. So real quick, on the side, real quick, I want this to make sense. So if I have 3, let me just make a different problem. 3x to the 5th over 12x cubed. I'm actually doing the exact same thing. Let me show more work than I would normally have to. Isn't 12 3 times 4? Isn't x to the, oh sorry, you can't see all that because I'm way zoomed in. 12 is 3 times 4. Isn't x to the 5th x to the 3rd times x squared? And why did I break it up that way? Why did I break this up like 3 times 4? Why didn't I break 12 up like 2 times 6?
So you can eliminate three.
Because I have a 3 up top. So of course I want to find a 3 in it, right? And up here, I got 3 x's, so why not break that top one up into 3 x's and 2? So what happens? That 3 cancels the same way that 3 x's cancel, right? And maybe. So I know I subtract powers when I divide because I'm losing that many of that thing. But that doesn't become subtraction of numbers. We know we don't just subtract numbers when we divide. We know that. So, in general, if you think when we learn something new, if you think that changes something we've done before, come see me because that's not correct. We learn new stuff. It can't change stuff from before, right? Okay. So coming back to this problem, what would I do next?
Distribute the negative 2 power.
Well, let's do it. What 2 things does that power tell you to do? What's the negative piece tell you to do? What's negative power mean? Flip, right? A negative power means flip. And then what's the 2 mean? Square. Right? So why do everything all at once? Let's do it one step at a time. So if I flip everything, that becomes this, yes? And now I still have to square things, right? So see how the negative disappeared because it did its job? And now I just square everything. 4 squared is 16. B to the 4th squared.
B to the 8.
B to the 8th, good. A to the 7th squared.
8 to
14. Shaboo. So you see how, so in mathematics, the people that are kind of able to do math easier, just out of nowhere, are the people that just naturally break things up into parts. We don't all just naturally do that. So I was lucky. I'm one of those people that sort of break things up. And I can see it. And I can totally focus on one piece and not give a shit about all the other pieces. And I think some students who are not the greatest with math, they try to keep the whole problem in their head. So look at that negative 2 power. That would so suck if you try to do it all at once. I mean, it gets really muddy. But break it up. Negative means flip. Okay, let me flip it. And then I'll square the damn thing, right? Because it's telling me to do 2 things. Let me do them one at a time so I don't get all freaked out. Okay, maybe.
Can you explain 2C?
2C. Oh, yeah, this is beautiful. No, you might disagree. All right. What's the main kind of thing in that problem that's a little different than kind of like a standard problem? Absolute values. I love it. Absolute values, where do they go in order of operations? Parentheses. I love it because they have stuff inside. So the very first thing I'm going to do in this problem is do the inside of the absolute values. They're like parentheses that somebody hammered out, right? Bam, 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 bam. Oh, yeah. So they work the same, except they have one extra thing. You can't just take them away. They make everything inside positive, of course, right? Real quick word about that, real quick. Side note. I'm getting too many people that tell me that the absolute value of x minus 7 is x plus 7. Is that true?
No, that's one.
You can see why somebody would think that, right? But what's the absolute value of 9? 9. If I said the absolute value of 11, isn't that 9? 11 minus 2, isn't that 9? If I make that 11 plus 2, that's 13. So the absolute value of 9 is 13. Do you guys see what I'm saying? So you can't, absolute value operates on the entire number, not a piece of it. So if you do this, you made a piece of the number positive and you left the other piece of the number the same, just like with the 11 and the 2. That can't be true. Okay, so coming back to our problem. Let's see. What would you? I'll figure it out. There we go. So what can I do inside this first set of absolute values?
Cube the 2.
Yeah, cube the 2. So that's 7 minus 8. All right, let's look at this next set. What can I do in there?
Distribute the 3.
Yeah, well,
Well, no, you can
4 minus 8 is?
4.
Negative 4.
Negative 4. It's 2.
Are you guys with me? You could distribute a 3. Why the hell would you? There's not two numbers. 4 minus 8 is freaking negative 4, right? I don't have to distribute anything. So 3 times negative 4 is?
Negative 12.
Is everybody cool with that? Okay. You could distribute a 3. There's nothing wrong with that. It just makes things worse than it has to be. All right, so am I done in here? Nope. So what's 7 minus 8?
Negative
Negative 1. Plus, and what's 12 divided by negative 12? Negative 1. And so what does this become? Yeah, so this becomes 1, correct? And then there's a negative sign outside. Is that cool? So that is 1. Then you put a negative on it. Plus 1, 0. So the absolute values are in the same order as parentheses. They just have the extra little thing about whoever's left alive inside, make them positive, right? Parentheses don't do that, of course, but absolute values do. Is that okay? Is that all right? 2B. G. To be or not to be? Not to be? Okay. Sorry, I always gotta make that crazy joke. Okay, so real quick. Do you see how that's the subtraction of two fractions? Subtraction, fraction, what's your action? Okay, sorry. So real quick. How would you do this? 5/6 minus 1/15. Right? And one really quick way to get a common denominator, 6 is 3 times 2, 15 is 3 times 5. Can you guys see what they each have in common? What do the bottoms have in common? 3. So they both already got a 3. What's the first guy missing the second guy has? What's the first guy missing?
5.
Yeah, so 5. And what's the second guy missing that the first guy has? 2. Do you see how they both have a 30 now on the bottom? You guys with me? Isn't that cool? If the whole idea of LCD is to multiply them up to be the same thing, factor them first so you see what they already both have in common. And just give each of them what the other one has that they don't have. Isn't that cool? I like to think of it like 2 kids with bowls of ice cream. Anybody here have any kids? Anybody here recently a kid? Okay. So you have 2 bowls of ice cream, and this one has a little more ice cream. What do you think is going to happen with the kids? This one's going to be like, I want more. And then and this one got sprinkles, and this one didn't. He got sprinkles, right? And me, thankfully, I don't have kids because I would just eat all the ice cream and say nobody gets ice cream. Right? So that would be fantastic, right? That would be great for me. So that's what this is to me. It's this guy had the sprinkles, he had the 2, and this guy had extra ice cream, he had the 5. So to make it even, I have to give each one what they're missing. And now they'll go away and eat their ice cream. Okay. So what's it got to do with this problem, Jeff? This problem ain't got all those numbers. Yeah, it does. What was the first thing I did over here? I factored it so I can see what they have. So what's the first thing I should do in this problem? Factor the bottoms, yeah. So what's this bottom become? X plus 3x minus 3, yes. Look for those difference of squares. Those are nice. And what's the other bottom become?
3 times x minus 3.
Now you can see what they have in common, correct? What do they have in common? X minus 3. So what's the first dude need?
3.
Yes, he needs a 3. He's got a 3, he needs a 3. And what's the second dude need? Now, whenever you have a minus in the middle, one thing you can do for yourself to remind yourself that the negative's got to go through is, how can I rewrite like 3 minus 5? Isn't that 3 plus negative 5? Can't I make that a plus and negative? See how now you're not going to forget to bring the negative through? So here I get 9x. Here I get minus 2x squared minus 6x, right? All over 3 times x plus 3 times x minus 3. So again, sorry. Yeah, now you can, I just wanna make sure everybody's with me so far.
Oh, okay.
And now you can simplify the top. Good, so it'll be 3x minus 2x squared over 3 times x plus 3 times x minus 3. Can I cancel those 3's? No, I can't, because there's a minus, right? I can't break into a subtraction problem. In fact, the top kind of factors, but it's not gonna have any factors with the bottom common, right? So I'm done. I can't kill anything, so I'm done. Maybe? Maybe. So do you start to see now, whatever we do with numbers is also what we do with variables, because that's all variables are. It's numbers we don't know yet. That's it. So if I need fractions, I need LCD, which means figure out what one has that the other one doesn't. Then with variables, same thing. I just break them up so I can see what they have and what they don't have. Maybe? Okay. All right. So let me see. Okay, it's 9 o'clock. Not too bad. I'll give the answer key out a little bit later. I got a flurry of questions. This is awesome. Anything else as you guys look through this thing? Yes? 5F? Oh, cool. This is really good because I didn't actually put this on the answer key. I said I was going to do it with you. So let me pull up the function that I'm talking about here. What was it? Page 212. Scheisse. Gosh. All right. Let me download the PDF real quick because this book is driving me crazy. Don't view it online. It's kind of freaky. Go away. Okay. Where are you? There you are. 2, 1, 0. Okay. Open. Okay. There it is. And then page 212. All right, number 53, I believe, right? Okay. So ignore the questions on this page. I'm asking different questions about this thing. So part F, so let me balance between these two things. Part F says to graph this. How many transformations are involved here? 3. What are they? What's the negative do? Reflect it around what axis?
X.
Around, yes, x-axis. What's the second thing? Second? Yeah, inside here, what's that going to do to it? Left 2. I love it. We had a lot of discussion about why that is. So it's going to make it go left 2. And then the final thing you do, because we follow order operations, is what's that going to do? Up 2. Okay, I like it. All right, so let's do this. Let me put this back up here. Get over. So there's the function we're dealing with, right? Let's give ourselves some points real quick. Doesn't it go through -3, 4, right? Are you guys with me? And it goes through -2, -3, yes?
Yes.
And then it goes through 0, 1. And then it goes through 2, -3. And then it goes 3, 4. Anybody know, is this like an x squared? Is this the graph of x squared somehow? Like 3x squared plus 7 or something? X squared should just be a parabola, right?
Mm-hmm.
This sucker has 2 humps to it, right? Anyone know what this is? I like that. It's a W, right, for Waller. How many turning points are there? 3. So watch this. How many turning points in a parabola? 1. And isn't it a second power? You guys with me? And there's 3 turning points here, so I'll bet you anything that's x to the 4th. That's some kind of x to the 4th. Maybe it's 5x to the fourth minus 7x cubed plus 2x minus 1, I don't know. But it's some kind of x to the fourth, I would bet you. So that's something we're going to learn more later this semester is the number of turning points is at most one less than the power, which is why it makes sense. A parabola has one turning point because it's the second power. So that's later, I just gave it to you now. Is that important for this problem? No, it's just extra, sorry, I do that. So let's come back to here. I'm going to try to graph that thing. So -3, what was it? -3, 4. -2, -3. 0, 1. 2, -3. And then 3, 4. Okay. 3, 4, Jeff. There you go. So it looked like. Oh, I should have done this dotted. I'm you, Jeff. I'm you to have. All right, screw it. So that was supposed to be my base function. I should have connected it with a dotted line. I'm so sorry. So I take a point. What am I going to do to that point? I'm going to reflect it around the x-axis. So this point will now go down here. You guys with me so far? Left 2, 1, 2. Good so far? Left 2, 1, 2, and then up 2, 1, 2. So now that point is there. Take the next point. Do you guys see what's happening? So all these transformations apply to the entire function. They apply to every point. So if I can identify a few points, I just do those things to those points. And by the way, what letter will it look like now after this? An M. How do you know that? Because it's a reflection is a part of it. So it should look like an M that's just been moved around. So let's do this next point. So here, first thing to do to this point is reflect it. So now it's going to be up here. Is that cool? Sorry? Oh, let me zoom out a little bit. And then refocus. All right. So this point, first thing I do is reflect it. So now it's here. Yes? And then I go left 2, 1, 2, and then I go up 2, 1, 2. So now it's there. This point. What am I going to do? I'm going to reflect it. Left 2, up 2. Bam. This point. Reflect. Left 2, up 2. Bam. This point. Reflect. Up. Well, I'm sorry. Left 2, up 2. Bam. I think I've got it. Yes. And then here's my M. M. Okay, you can probably do better M than me, but I went too fast. So that's what I'm going to ask on the, I think I said it here, didn't I? No, I did not. On the test, I'll say list the transforms. So I want you to list in order the transforms that you see. I am going to let you use graphing calculator. So there's a way just to make the calculator spit it out at you. But your work, your graph, better match your work. The worst thing you can do in this class, this is huge. The worst thing you can do in this class is to give me a perfect graph that does not match the work you did. You with me? Because then you're going to lose the most points because you just got that graph out of your calculator. Get out of it. Maybe, okay. Is that all right? So I knew it was going to be an M before I did anything because there was a reflection involved. So at least I know the shape of it. So I just need some points so I can just fill in the shape. Is that all right? I mean, do you guys, on one level, I want you to go, oh, cool. That's all that shit is. Figure out how things move and then make a move. And then reconnect them. That's what transformations are. That's it. And you're like, it's easy for you to say. I'm sorry. I'm sorry. It really is all they are. Okay. How do I check my work? Anybody? Well, it's kind of hard to check your work because they didn't really give you the function. So if I would have given you the function, you could have just picked it. Remember, we pick a point. We plug it in and see what we get. Yeah, there is sort of a way to do it. It's a little bit freaky. So that was a good question because it's not on my key. I want to do that with you in class anyway. And that's a really shitty graph, but you know, it's pretty close. The point of this really is just being able to move it. But you know, take a little more time than I did to try to connect it. Anything else? And it doesn't have to be on the practice test, right? It can be in the homework, it could be just generally, right? You could say, show me how the hell to factor cubes again, Jeff? Yes?
So in the homework, it says, determine the function and non-function.
Yes.
Is there like a certain equation we're supposed to do, or like?
No, so are you talking about the ones that had like, x squared plus y squared equals 9 or something?
Something like that. Or is it just say, function?
So they gave you a bunch of equations, right?
Yeah, and
And they said, tell me if it's a function, right? Function of x, they said very specifically. So watch this. Is this a function of x? That is, I'm just gonna tell. Isn't that y as a function of x? Like, and a way to say that is y determined by doing shit to x? Yes. And in fact, if I put a number in, how many outputs do I get? How many y's do you see up there? 1. So every x I put in, I'm going to get 1 y out. And isn't that the definition of function? So if you can solve some given equation with x's and y's, if you can solve it for y equals one thing, function. It's a function of x. So what about this? What do you got, Jeff? What about number 2 there? Say again? What do you have to do if you try to solve for y? What do you have to do? Add x to the other side and then do what? If I take a square root, what do I have to put here? Plus or minus. Holy shit. So do I get y equals one thing?
No.
Oops. I get 2 outputs for every input. In fact, I think I showed you this real quick. Remember, this is a parabola that kind of is on its side. This is y equals x squared. This is x equals y squared. Is that a function that doesn't pass the vertical line test? Nope. Do you guys understand how to do that? So if you could, you don't have to solve for y. It doesn't say that. So you don't even have to do the work. You just have to think, if I try to solve for y, oh shit, I put plus or minus. It's not a function of x. Because there's 2 functions of x, so it's not a function of x. Maybe? Is that all right? I forgot who asked the question.
Because like I was doing it, and I didn't want to like get one statement to just send function.
Oh, but give me some kind of reasoning. You can even just say, I'd have to put a plus or minus square root, so no. You just say that. You don't even have to do the work. You just have to, because it didn't say solve for y.
Right.
Okay, I like it. And yes, there will be some problems where there's really no work to do, right? So I understand. You don't have to show work every single. If I say 3 times 4 and you're like, let me write 4 3 times, and then add, no, come on, you know. There are problems that don't require any work, so yeah, okay. Anything else? I might give you the key so you can kind of look through it. Check it all, make sure I got it right. It is in my handwriting, so that'll be fun. I'm so sorry. If you wanted to be able to read what your teacher wrote, you chose poorly. So let me go ahead and give you this so you have a chance to look through it. Please don't do this. Don't, if you haven't looked at the practice test, don't get this answer key and go, yep. Yeah, I would have done that, right? Because then you're building false confidence. It's easy to agree. The test isn't going to be, here's some work that I did. Do you agree with it? I concur. It's not the way it's going to be. So hopefully that makes sense. Also, like I said, builds false confidence. Yeah. But if you want to, you can. If you want false confidence, that's how you get it. Also, don't try the practice test problems like 8 times until you get it right. Because then you know that problem, you don't know how to do that kind of problem. That's something else students do sometimes. part of it. Put on just a blank sheet of paper. So let me know. I am averaging about a 97 on my answer keys. So I am not a teacher that will say, I know math, I don't make mistakes. I make frickin' mistakes, of course I do. So if you see something you think is wrong, let me know. Pretty sure these are all right, but, you know, I'm human. Say again?
Oh, I think the 2B are supposed to be on multiplication first, then division.
What do you guys think? Nope. You do it as it comes. So the whole thing I try to make clear about order operations is, does anyone remember the way we should write it? I'm not sure how you would describe it to me. So don't write it like this. Don't write it like this. These are both equally important.
Okay.
Neither one comes first. You do them as they come. I personally know instructors who teach that multiplication comes before division, and they need to stop teaching, right? That's just completely wrong. So if you've ever had a teacher that told you that, I'm bound to believe you because I know they exist, and they suck, and they need to stop. That is so just not right. And it's really simple to see why. Give me a second here, let me see. 4 minus 8 divided by 2 times 6, okay. So I see a lot of people write that as 4 minus 8 divided by 12, right? That does not make sense. What's the only number that would be on the bottom? If I rewrote division as a fraction, right? Isn't this like this? Times 6? Isn't the 6 up top? So if you make it divided by 12, how the hell did you make that 6 go down? How did you do that? Does that make any sense? No? This is why you do as it comes. I'm definitely going to do the subtraction last, because that's the ass end of PEMDAS. I know I make that joke a lot. I don't care. But here, that's why 8 divided by 2. That's what I do first. Why? Because that's how I rewrite the division. The 2's on the bottom. Now what's 8 divided by 2?
4.
Times 6. If you write it like this, isn't there another way to do it? 2 goes into 6 times 8, 24, same answer. So as long as you put things in the right place, math does allow you to do some stuff out of order, but as long as you have everything in the right place. So you can't make it 12 because you shoved that 6 down and made a new problem. You're like, I like your problem, Jeff, but I want to do this problem instead. You're going to lose points. Maybe? Does that make, please let that make sense. And again, I'm really sorry if you had a teacher that taught multiplication before the division. Again, I know they're out there, and on behalf of my profession, I'm sorry, right? But I'm just telling you right now. Does it make sense now? Why? I can't do multiplication before division. It doesn't make sense. It just, is that clear? It just doesn't make sense. Okay, maybe? Okay. Anything else you guys notice or have questions about? I kind of did number 3 a little quickly. Number 3 might be a little weird. Anything that you're not clear on in number 3? Is there any part of that you've forgotten what it means mathematically?
All of it.
Say again?
All of it.
Okay, all of it. All right, so why didn't you ask that earlier? How do you find the equation of a line? Just what do you need to figure out the equation of a line? You definitely need the slope. What else? Y-intercept or a point, right? Do I have a point?
Yes.
Yes, sometimes I have a point. Point is -1, -3, right? Check. Do I know the slope of my line? Do I know it? No. Check. Do I have information related to the slope of my line? Yes, my line is perpendicular to that line. What the shit does perpendicular mean? It makes a perfect 90-degree angle, right angle, right? All right, what does that mean? Two lines that are parallel. What's true about their slopes? They're exactly the same. So two lines that are perpendicular, their slopes are completely opposite. There are two ways to make something opposite. It's the negative reciprocal, right? So what's the opposite? Here's a weird question. What's the opposite of 3? It's not what I'm thinking, then. That's 1/3. So, sorry. The word opposite in math is not specific enough because there's an additive inverse and there's a multiplicative inverse, right? Do you guys agree with me that 1/3 in at least some sense is the opposite of 3? Do you guys agree with that? But obviously we think -3 because we use addition more often than multiplication. So, if I have a line that is perpendicular to another line, if I know that line's slope, my slope is the negative reciprocal of that. It's the complete opposite. Parallel, totally the same. Perpendicular, completely opposite. So what is this guy's slope? What's the quickest way to figure out his slope? Sorry?
I was gonna say,
Yeah, get the y by itself. So add 5, and then divide by 3. So what's this guy's slope? 2/3. Do I care about this? I don't care about that. All I need is his slope. So what's my slope going to be? Yeah, our slope is going to be -3/2. And then once I got a point and the slope, what can I do? Yeah, I could either do, now I need more room again. I could either do the y minus y1 equals mx minus x1, right? Or I could do yx equals mx plus b, plug stuff in and solve for b, either way. So let's do this way. Y minus what? -3 equals -3/2 times x minus -1. So that becomes plus, right? Y plus 3 equals -3/2 x minus 3/2. Is that cool? Bam, bam. And then last thing I could do, subtract 3. Y equals -3/2 x. -3/2 minus 6/2, right? So -9/2. So anyway, so I caught up to the work I did here. The thing I didn't show you is how I got -3/2. And in fact, I almost didn't even get it myself at first. Yay, Jeff. Is that all right? Remember that perpendicular thing? Anybody? It's the complete opposite. Okay. If it was parallel, I would have just put 2/3 here, right?
Right.
Because two parallel lines have the same exact slope. Yeah.
How do you do 2A?
2 here. This guy here, right? Oh, did I have 2 of the same kind of problem? Oh, I did. Neat. I don't know why I put 2 of the same kind of problem. Okay. So it's exactly like G, which I think we did earlier. So what did we do to get 2 fractions put together? Yeah, factor the bottom so you can see what they have. We can make them show us what they are working with. It's just a joke for myself. How do you factor the bottom of this other guy? I can't take x squared out. You can take an x out though. What's left? X squared minus 1. And then of course this goes further. How do you factor x squared minus 1? Okay, I'll take either way, yeah. Okay. And now you can very quickly see who's missing something. Yeah, the first guy needs an x plus 1. If I give him that, they both have the same thing, right? So I have 5x plus 5. Now I'm going to make a mistake. I've made a mistake.
You didn't distribute the negative.
Oh, shit. Right? I've got to distribute that negative, and that should be a minus 1, right? And then you just put your like terms together, and you see if you can reduce it. Is that cool? So that's what, hopefully I got 3x, what did I get? What was it again? 2a, yes, Jeff, pass Jeff, did it right. Yay. So you just combine like terms on the top. So that's a beautiful example of variables have to act the same way as numbers because that's all they are. So we actually did all the same work we would do if it was numbers in a fraction. I really hope you guys can see that. I mean, that's, to me, a really huge thing to realize as a student is all the variables have to act the same way numbers do. Because that's all they are. Okay, maybe. It's not really hot in here, is it just me? Is it warm in here? I've just been moving around a lot. Okay.
3, 8,
8.
that'll be all
8. D, this guy?
D, yeah.
This guy, okay. So the difference between this guy and the problem we just did is this is an equation. So in this problem, I am allowed to multiply both sides by something. So what I show students is, how do you factor this guy right here? Isn't that exactly what these are?
Yes,
So what's the first guy missing?
next minus
What's the second guy missing?
1, x plus, x minus 1.
Now, it's an equation. I can multiply both sides by 11 billion. I can multiply both sides by y. I can multiply both sides by whatever I want to. What does it make sense to multiply both sides by? Say again? Yeah, if I multiply both sides by x minus 1, x minus 4, don't all the bottoms just disappear?
Yes.
All the fractions will be gone. That sounds good. So let's multiply both sides by x minus 1, x minus 4. So die. Okay. So what do I get? I get 5x minus 20 minus, oh shit, minus 2x squared minus times minus is plus 2x equals 3. I think that's what I get. Yes. You guys cool with that? Just distribute, right? Okay, and of course that negative has to go through everything. And then how would you solve that? Combine like terms. You have an x squared piece, which means I'm gonna have to set it equal to 0 so I can factor, right? I would move everything to the 3 side because that would make my x squared term positive, which makes factoring easier. I think I caught, well, let's see, what did I do on that answer key? Bum, bum. Bum, bum, bum. Oh yeah, this is where I really jammed it in there. Holy shit. Oh, I didn't even finish it. Yeah, okay. So let's see if I get the same thing. 2x squared, add 20, that's 23. 5x and 2x is 7x and subtract 7x. Okay, so I do get the same thing. Oh yeah, this is, can you factor that? Hell no. 2 times 23 is 46. The only way to factor 46 is 2 and 23. So I just kind of lost interest because what do you do now? If you can't factor a quadratic equation, what do you use instead to solve it? Quadratic formula. That's where you just plug shit in, right? Don't go right to quadratic formula, by the way, especially if it's not an equation. So that's what kind of drives me crazy. You guys are so, I don't blame you. You learn about equal 0. None of these are equations, correct? So you're not going to get answers for any of those. They're not equations, so don't make them equal 0. That's so nihilistic. Everything is 0. Just think about it. No, it's not. I don't know what they are. Don't make equations out of them. Does that make sense? Maybe? Okay. It's that one just factor. It's not equal to anything. So can I use quadratic formula on any of those problems? No! They're not equations. You could, but you have to interpret what you get, and it gets a little weird. Maybe? Is that all right? Okay. So why was I allowed to kill the fractions in this problem, but not this problem?
He let you?
Say again?
He let you?
I let you?
Yeah.
Wow.
It's not an equation.
No, I didn't. Huh? That's not an equation. How did I kill the fractions of the problem? I multiplied both sides by the same thing. Do I have two sides to this? No. There's no equal sign. Do you guys see that? So a lot of students are like, well, wait a minute, you killed the fraction there. Why can't? It's not an equation. I don't have two sides to balance me out. Okay, maybe. You guys look beat up. I'm sorry. Yeah, that's what pre-calc does too. I know. Okay. Okay. I really, really hope the transformations, that compared to some of the other stuff we do, this should actually be like, oh, okay, good. I can just do that, move stuff, retrace it. It isn't that big of a deal. And the reason we learn it is because now I can graph a function relatively quickly. Instead of making a big XY table, I can just kind of move it around. Okay. Anything else on here or in the homework? There's a nice one, graphing the base function. I think I did that, right? Yes, I did.
Yeah.
Yeah, list the transforms. That's the way I would do it. List the transforms. Right? Okay. Anything else? Let me say this and see what happens. If you don't have any more questions and you're ready for the test, you can head out. That's fine. It's always fine. Right? If anybody out there is like, God, just shut up, dude. Let me walk out the door. You can do that anytime. It's college. You don't even have to be here. So I appreciate you're here. Are there any other? And I know then I get people just kind of stay because they're like, somebody might ask a question that I want to know the answer. Anything else? Homework, practice test, general questions. While you guys consider that, I did mean to put this up here. I don't know if you guys know about the success coaches. I think they could have given it a better name probably, but basically what a success coach is, anybody ever know anything about the success coaches? Did you know we even have them?
No.
They're kind of like a one-stop shop. If you have any issue that is making it difficult for you to learn, right? Anything. You have trouble getting to college, you have food insecurity, you have mental health problems, you have physical health problems, you have anything. You come to these guys. You explain the situation and they will connect you with all the services Grossman offers that address those things. Does that make sense? So you guys know we have a food pantry for food insecurity, right? We have mental health counselors that you can access for free. We obviously have a nurse's station that you can access for free. We have silly amounts of stuff, yes? So here's their information, but even better than that, on our Canvas shell, you see, where is it? There's the Student Support Hub. That could load some, there we go. And Success Coaches right there. I also have student support links. That goes to this one. It's got even more stuff, and Success Coaches are down here. So the Success Coach could tell you which of these things would help you in any situation that you have. Does that make sense? Right? If you think I'm an evil person, I'm mistreating you, you can go talk to them and say, I think my teacher's an asshole. What do I do about that? And they'll send you to the right person. They'll send you to my chair, probably. Please keep me in line. Keep any teacher in line. Don't just accept some teacher's abuse, right? Yes?
For the homework up to chapter 3.5?
Say again? Yes. Homework that is due tomorrow is through 3.5. If you can't quite finish it, do enough to get ready for the test tomorrow. You can tell me, I didn't really get much done. I just did a couple problems out of 3-5. Can I give it to you next time? And I will say, yes, as long as you do enough to get ready. Does that make sense? The whole reason I make homework due the day of the test is because the homework is the best way to study for the damn test. So I'm trying to kind of motivate you. There's a reason to get it done. Okay, sorry. I really got to cut down on the coffee. Anything else? Like I said, some people, in fact, you can leave. It's okay. Yes?
3.2, question number 36.
3-2. Let's see, where am I? I'm in 3-1. 3-2. Scheiße. I'm in 4-3, please. 4-1. Ah. I'm trying to get around this thing. Here we go. I'm in 3-2, yeah. Which one again? Which problem?
36.
36. Okay, this guy, what's it say? It says domain and range. This guy here, right? The guy with the little monocle here. Oh, shit and a half, Jeff. Damn it, hold on. Oh my god, this thing is so touchy. There it is. Okay, I'm so sorry. Gotta just move you up a little bit, thing. Okay. Domain, of course, relates to which variable? The x variable. And range relates to the y variable. Now this is a little bit evil because where that circle is a little hard to tell. It's not really on -2, is it? So what would your estimate be where that circle is? What x? It's not -2. Do you see that? It's a little bit below. Does that make sense? So that might be the hard part of this problem, but whatever it is, do I include it in the domain? No, because it's open circle, right? So what do you, let's just say -1.8 or something. Does that make sense? I mean, -2.2, go the other way then. -2.2, like it's a little bit below -2, is that right? So -2.2 with parentheses. And what's the last x that has an output? Well, over here I see an arrow. Infinity, 11. And of course, for the range, what's the lowest output that I see?
-4.
Yeah, I don't see it. -4. Up to infinity, 11. It doesn't matter that this one stops because this one keeps going. So there are outputs all the way up the y-axis.
Do you include 4 since it tilts there?
Oh, it's a closed circle, yeah.
Okay.
So include -4.
And I saw this on the answer key, but if the arrow is on the other side, do I have to put negative infinity?
Yes.
Because I haven't been doing that.
Oh shit.
So you have to put negative infinity?
Yes.
Okay.
So if there's do you see how it's going up really fast, but it's still moving over. So -10 does have an output, just way the hell up there, right?
Okay. Yeah.
So it has outputs for every x all the way down.
So you can't put like infinity, comma infinity, it's be negative infinity, comma?
Oh,
infinity?
yeah, exactly,
Okay.
right? So that's infinity, that's negative infinity.
Okay.
Yeah, good. You can't call them both infinity, I love it. Because it is a technically positive infinity, negative infinity. We just don't write the plus sign. Yeah. I like it. And please don't put, I still have people putting like a little tick mark, put an infinity there. Is that where infinity is? Right above 10? So don't do that. Don't do that, because you can't find infinity. If you put infinity, what the hell is right above that, right? I like it. Make a really dumb Toy Story joke right there, but I won't.
You always write the smaller number first.
Yes, it's always from small to big, right? You wouldn't, it would be weird to say, you can be anywhere from 30 to 11 years old, and you, what, 11 to 30, what the hell is your problem? So yeah, from small to big, yeah. Yes?
Can you do number 7 on the practice test?
Number 7, ooh, yeah, I was wondering why nobody asked me about this. problem. I love this problem. You would, Jeff. All right, so the sum of the base and the height of a triangle is 46 centimeters. If the area is 120 centimeters squared, find the base and the height. So obviously, what are the players in the problem? What do I have to give math names to? And why do I say obviously? Because I say them twice.
Base and height.
Base and height,
Total
right?
area.
Area is how they relate to each other. The players are the base and the height. Now, I know that they add to be 46, so can they each be anything they want to be? No. If I make the base 20, what must the height be? 26. If I make the base 1, what must the height be?
45.
So if I make the base b, what must the height be?
46 minus B.
46 minus b. It must be the rest. So if I call the base b, or x, or whatever, then the height has to be 46 minus b, the rest, right? So I'm not going to call them b and h, because that says they can be anything they want to be. Nope, nope. If I know one, the other one's got to be the rest. Then it says the area is 120 square centimeters. What's the formula for the area of a triangle?
1/2 base
1/2 base
times.
times height. And what did we say so the base is b. What did we say the height was?
46 minus B.
46 minus b. 46 is an unfortunate choice for a number because it looks like my 6's look like my b's. What's the worst part about that little equation that I have to work with?
Distributing the 1/2 B.
Well, then don't. I would multiply by 2, so I kill the 1/2, right? See how I can just multiply both sides by 2, and the fraction goes away? Are you guys with me on this? Do you guys see how I just put this together? I identified the parts. I gave them names, math names. I set up the equation using those math names, and now I just solve the equation. So I can multiply by 2, and then I can distribute the b. So I get 46b minus b squared equals 240. Now, what tells me how to solve this? What do I do to solve this? I'm doing all right? Yeah, I guess so. Can I just solve for b directly right now, the way it is? Why not? What's the highest power I see on b? 2 squared. Can I get all my b stuff together? Are they like terms? No, so I can't, so I gotta do it a different way. I gotta get the equation equal to 0 and then factor it. So if I see a higher power than 1 on variables in an equation, I get it equal to 0 and I factor it. Right? And that pretty much, did I squeeze it on there? Number 7? Yeah, I squeezed them. See there? That's the, what you get. See, there's where we just got to. And then this is how to factor it. 6 and 40, make 240 and then make 46, right? And so what's interesting is, it doesn't matter if the base is 6 and the height is 40, or the base is 40 and the height is 6. Those both meet the requirements. Right? I can have a very wide, squat triangle that have an area, or I can have a or if I push it in, then the height's going to go up right here, and it still has the same area. So that's why there are 2 sort of answers to this question. I expect 2 answers. Why? Because it has a square in it. Okay, maybe. Now, if one of those answers would have been negative, what would I have done? Would I have given it to me as an answer? No, I would have crossed that shit out. Because this is a physical problem, right? This is a triangle sitting on a desk. If it's got a negative side length, I'm not going anywhere near it. What is that? Is it going to suck me in? What's going to happen? I don't know. Okay. Anything else, guys? So again, so one thing about tests, you don't want to be stuck doing them 1, 2, 3. I would scan through the whole test, find something that looks the most familiar, and do it. Does anyone play any sports? Anybody play basketball specifically? Nobody plays basketball? Fine. What sport do you guys play? Who plays sports? What do you guys play?
Ice hockey.
Ice hockey?
Tennis and soccer.
Tennis and soccer. When you're warming up for tennis, what do you do?
Normally just hit against the wall or with.
Hit against the wall. Are those difficult to do? No, it's easy. What are you doing it for? Just to kind of warm yourself up, get your muscles back in their muscle memory, right? Probably ice hockey, you probably do some warm-ups, right?
Lots of them.
So on a test, you do warm-up. You find, okay, that one, I know what it's asking. I know how to do this. Warm up. Get your brain in the mode of math. Don't do number 1 and go, I can't do this, I'm screwed. No. Leave number 1, I don't know what it means. Somebody, oh, I know what this means. And then you sort of start to get back into that math mode, right? Okay, maybe. Yes?
For, still in section 2, I'm still having trouble with the piecewise functions for,
Number, which section?
3.2.
3.2.
For
Number
42.
42. I think I'm in 3.2, yes. Okay. What's this say to do? Sketch a graph, okay. Let me see. So this problem here, they want us to sketch a graph, right? Let me copy that down, and then we'll do it, and then that might be it for the class. Oh, I got some room here. Okay. I'm going to copy it down. Okay. Oops, I wrote it down. Okay. So this has got a little bit of a twist to it. So for inputs, for negative inputs, what does the graph look like? It's positive, that's right, but what's it look like? What shape? For inputs less than 0. It looks like a parabola, yes? Do you guys see that? It says, which piece of the function do I use if my input is less than 0? X squared. So I know it's going to be parabolic back here in the negative x's. Yes? I already know this side of it should look like this. I just got to get some points just to put it down, right? What's it look like for positive x's? What's it look like? A line. With what kind of slope?
Negative?
Negative. It's 1 minus x, so the slope is -1, the y-intercept's 1. You guys kind of with me? All right, so let's see. One way I can do this, like I told you guys, I can make a table of values for x squared. Am I allowed to use 0?
No.
But I'm still going to put it in, because I'm crazy, but I'm going to put it in parentheses so I know where to put the what. What's going to have to be there since there's a value I'm not allowed to use?
Open circle?
Open circle, but I got to know where the hell to put it. So I'm going to put when I put a 0 in, I get a 0 out. So I know there's an open circle at 0, 0, right? All right. And you would, okay, just to get there, you put the scale on there, okay. And then 1, 1, I'm sorry, -1, -1. Yeah, they're -1. -1 is slow down, Jeff. So I'm going to put inputs that are below 0 for x squared, correct? So -1 goes to 1, -2 goes to 4, right? And that's enough for my shape. Yeehaw! So I knew it was going to be parabolic on that side because that's exactly what it says. Now, what about the other side? This is 1 minus x. So again, I'm going to put 0 in, even though I'm not allowed to use it. When I put a 0 in, what would I get?
1.
1. So there's an open circle at 0, 1. And then let's put in 1. If I put a 1 in, I get 0, right? If I put a 2 in, I get -1. Is that you guys with me? So 0, 0, 1, 0, 1, 1, 0, and 2, -1. So it looks like it's going like that. Done. Right? So I think students, again, I think they try to think about the whole thing. No. For inputs less than 0, it's x squared. So I only worry about x squared. I make points, then I plot. Inputs above 0, it's a line. So I only worry about inputs above 0, and I only worry about making it a line. Maybe? The biggest mistake I see is somebody puts this here, and this goes, what's wrong with me just continuing this parabola? Is it a function then? Nope, it doesn't pass a vertical line test. Holy shit. That's why one's got to stop and the other one's got to take over, so that it does pass the vertical line test. Okay, bye-bye. Okay. So maybe, watch, what could this physically mean? This is a little bit weird. This is my company losing money, and then we get a big, somebody donates some money, and then we start losing money again. Right? I mean, that's possible. I mean, open circles are weird to handle for a physical problem, but that could be why a function is not continuous, or it doesn't meet, is because there's a sudden increase of something. Somebody just gives me $1,000. Then I just, in no time at all, went like that, right? Okay, all right. I think that's enough, guys. Yes. Okay, so again, I'm in the Math Study Center a lot. I'm in here right before class tomorrow morning. So it's up to you to come get some help if you need it. Otherwise, I'll see you guys tomorrow. Was it chapter 3? I didn't finish grading the chapter, sorry. Yeah.
Yeah, I finished my homework.
Say again?
I finished my homework.
Chapter 3?
I finished my homework, chapter 3 and something.
Oh, today? Oh, okay. All right. I thought it was, okay. Thank you.